Hey folks, the next thing we have to learn about in terms of inequalities is learning how to solve inequalities using addition or subtraction. And what our goal is here is to produce the simplest equivalent inequality that we can. And an equivalent inequality is just an inequality that has the same solution set. So we want to take a more complicated inequality like this one and simplify it as much as possible so that we just have a variable on one side and a constant on the other. We're going to approach this the exact same way that we approached solving equations. You solve inequalities almost exactly like you solve equations. There are a couple of exceptions to that rule, although those aren't going to come up in this lesson. But you can see here that this is x minus 6, and so we need to do the opposite of subtraction of 6. We need to add 6 to get rid of the 6 to isolate x. That is, to get x all by itself on one side of the inequality. So if we add 6 to both sides of the inequality, the negative 6 and the positive 6 cancel each other out, and I'm left with x is greater than or equal to negative 4. If we go ahead and plot this on a number line, because this is a greater than or equal to symbol, we do shade in the number 4. And because x is greater than or equal to, we head off in this direction and shade the arrow this way. So that's the basic procedure for solving an inequality in terms of the addition and subtraction component. You do the opposite of, you kind of go in reverse PEMDAS order, and you do the opposite of the operation that you see in the inequality. So let's do another example here. Negative 8 is less than 1.4 plus m. Well, here, m is on this side of the equation, and I'm trying to get m all by itself. 1.4 is being added to m, so to get rid of the 1.4, I want to subtract it away. I want to subtract it away from both sides of the inequality. And when I do that, then I get negative 9.4 is less than m. Now, if we're being asked to graph this, remember that in order to avoid confusion, it is best to write the m at the start of your inequality, write the variable at on the left-hand side of the inequality. So I'm going to write the m over here because the inequality sign opened towards the m here in my solution. I'm going to make sure that my inequality sign opens towards the m when I rewrite the solution. And this notation makes it easier to graph this one on a number line. So if I want to graph this one on the number line, I would go down to negative 9.4, might be about here, negative 9.4. And then I want something that is greater than, not greater than or equal to, so I drew the wrong symbol here. Let me draw an open circle here. Let me erase this one and draw an open circle here at 9.4. And then we want this inequality to extend up in this direction. So notice kind of the procedures that we're using here. These aren't really coming into play yet because so far we're only dealing with addition and subtraction to solve our inequalities, but we are going to use the same procedure that we did when we were solving equations. We're going to simplify any expressions that we have. We're going to solve inequalities in reverse using reverse PEMDAS, and any addition or subtraction done to one side of the inequality we are going to do to the other side. So just to be totally clear on that, let's go back up here and see the kind of definitions, this other definition that we had. The addition or subtraction property of inequality says that when you add or subtract the same number from each side of the inequality, it produces an equivalent inequality. And so when we solve this inequality and get a simpler version of our original inequality, that is an equivalent inequality because of the, in this case, the addition property of inequality. Let's look at a real-world example of of one of these involving electricity. So I have a circuit that's going to overload at 1800 watts of electricity. I have a 900 watt amplifier plugged in. Which other pieces of equipment listed can I plug in? So I have 1800 as a maximum and not equal to, my circuit will overload at 1800. So this is whatever I have with my, I don't know, whatever electricity that I have. I have 900 watts already plugged in, and I want to know how much additional wattage I can add in. So this kind of represents what I have in my inequality thus far. If I subtract 900 from both sides of the equation, I get E is less than 900 watts. So I can choose electrical equipment that adds up to less than 900. So if I look here, I can do the lighting machine. That's less than 900. I can do the fog machine 1. I can do fog machine 2. Or I can do the TV. And in fact, I can plug in more than one thing. I could do the TV and the fog machine, or the TV and the other fog machine, or the TV and the lighting. So I could do TV and fog machine, the TV and the other fog machine, or I could do the TV and the lighting. So there's 1, 2, 3, 4, 5, 6, 7 possibilities of things that I can plug into my circuit without overloading it. But if I do any more than those 7 examples, then I will overload my circuit. I hope this helps.